So here we go, complex formation. Come, let's take a look again. Now, a complex contains a central metal ion or atom or ion dative bonded to one or more surrounding molecules or anions called ligands. So again, there's a few so-called, what's the word to use? A few definition you need to know. Complex ions. So once again, not all complexes are ions. Some complex are compound, some complex are ion. All right, be very comfortable with it. Once again, okay, then that's where we come in and we talk about ligands. Ligands can be monodentate, bidentate, even tridentate. Okay, and then it can be hexadentate or more hexadentate, which we all call them the polydentate. Okay, now here we go. Okay, I want to like change a bit of things over here to make it more precise. Now, what do we call polydentate? Poly usually means what? More than one. So I have a question. Do you think I make a mistake here in the notes? Do you think this is by this? Should I call it polydentate also? Technically, yes or no? Simple question for you, right? Because the question come out polydentate, I need to know what actually is polydentate, right? You agree with me? Make sense? Correct? So what is the dentate over there is all about the lone pairs in that molecule or the ion that can be contributed to the transition metal and ion. Make sense, everyone? Okay. So I will just change this again. All right. So once again, all the bidentate, it has two lone pair. And I just want to recap back on the lone pair. Now, if you take a look at ethane dioxide ion, all right, there's all a lone pair there. The one that is being contributed must be the one that has a negative charge. So you choose this side, you won't choose this. You are not going to choose this, but you're going to choose always from here. Make sense? It must have a negative charge. Because ions are unstable. So they want to kind of remove or reduce that negative charge itself. So it must be from here. Because in exam, they'll give you a ligand, and then they ask you to circle, all right, the lone pair of electrons over there that will be dative bonded to a transition metal atom or ion to form a complex, so on and so forth. So it always from there. Okay, so be very clear. Now, this bidentate, can I just write here and change this to, there's a lot of dentate. So let's change this to hexadentate. If you want, let's have another, let's have a tridentate come out. All right. Can I easily form a tridentate? I think I can easily. All right. So let's model after the bidentate. I'm going to use an amine. So I just have to create an amine that has three lone pairs. That's it. CH2, amine looks like this. Lone pair, CH2, and H2. Should be balanced, I believe. Okay. All right. So this is a tridentate. Then I want to shift the polydentate over here. All right. Polydentate, it refers to poly, once again, is more than one. So this refers to your so-called more than one. So all example, this anything that is more than a bidentate. So more than a monodentate. Right. So bidentate, tridentate, and anything that's higher than that. Etc. Okay, do get this down. Now, because polydentate, all right, this kind of ligands, when they form a complex with your transition metal ion or atoms, they become, or the complex has a name. Okay, so it's good to like be aware of it. Now, all these polydentate ions, they are known to be very good chelating agents. Okay, they are known as very good chelating agents. So any one of these, when they so-called attack the transition metal atom or ion, they form a complex. All right. The complex that's formed has a name, which is from the chelating words. It's called chelated compounds. And chelated compounds tend to be very, very stable. Dynamically, it occurs. And this is what we actually discussed right below here in the hexadentate example. Okay, so here we go. Anything that's more than a monodentate, right? They are very, very good, ligands, very good, what we call chelating agents. All right, so here we go. I go back here again. Okay, complex. Let me make it bigger once again. All right, we need to know all these terms very well. Complex formation. A complex always contain a central metal atom or ion. Once again, there's dative bonded to one or more surrounding molecules or ions called ligands. So that is what we call a complex. Formally, in transition metal, especially. Now, if the overall species, all right, carries an overall charge, if the species, whatever that's formed, carries an overall charge, then we'll call it a complex ion. And a complex ion, once again, is a charged species. It has a charge, positive, negative, which consists of a central metal ion that is, once again, dative bonded to one or more surrounding molecules or anions called the ligands. So, for example, all right, these are the complexes that are being formed. This is a neutral complex because it has no charge. But the one below over here, they are also known as complex, but they are known as complex ions. Obviously, they are ions, so we call them complex ions. But because they have that dative bond between the ligands and the central metal atom ion, so it's known as a complex. What about ligands? Ligands, all these you love to ask, let them come out. A ligand is basically an, let me just change the color, ion or molecule that once again have at least one lone pair of electrons that can be donated into a vacant, empty, low-lying, usually d orbitals, right, of the central metal atom ion, again through dative bonding, and result in the formation of a complex. So again, the complex could be a neutral complex or a complex ion. If you look at it, then what are really ligands? Ligands are therefore very good Lewis bases. Right? What are Lewis bases? They are basically lone pair donors. Donate to who? Donate to the transition metal central atom ion, which acts as Lewis acid, because Lewis acid are lone pair acceptor. What are lone pair donor, lone pair acceptor? Lone pair donor has the lone pair. Lone pair acceptor has the empty, vacant, low-lying orbitals. Make sense? That's what we learned. So we combine them together. So using this, all right, you realize ligands tends to be what also? So ligand tends to be Lewis bases, we discussed. And in organic chemistry, that's why we combine them together in the question. Ligands are also known as what? Very good. Keep coming out. Nucleophiles. Because it's all about the lone pairs. If we have the lone pair, we are very good with that. Okay, can done. Transition metal ions, once again, standard answer, give it to them. Whole chunk here. They have low-lying vacant d orbitals. All right, so they can accept that lone pair electron. But beside that, they are also very small and frequently highly charged. And whole idea is they have very high charge density because they are metal ions. Remember, if they're ions. And if they have high charge density, they have high polarizing power. And these are all the standard answer, right? Strong tendency towards covalent bond formation with ligands because they're going to pull them towards it. And then once again, the low-lying vacant d orbitals is there to accommodate the lone pair electrons from the ligands. And therefore, they tend to form dative bonds and thus the complex that you want. Talking about ligands once again, all right, they can be classified based on the number of dative bonds they can form with the central metal atom or ion. Very easy. All right, comes from all the English words. Just now I jumped the gun a bit. I thought we're on par with Saturday. We are slightly slower. All right, it's okay. Monodentate, all of them, all right, has only one lone pair electrons that can be donated. Okay, so this tends to be all your monodentate. Now, I want to give you two monodentate that is of particular interest. Okay, first of all, this one is known as a what ion? Cyanide ion. The lone pair come from carbon or nitrogen. We did this, we saw this in organic chem probably before. Because ammonia or alcohol, all this no problem. You agree with me? So I'll give you a few more. Hydroxide ion, you also know where is it. Right? It's all on here. Make sense? What about, right? I'm going to give you a few, right? Carbon monoxide, right? Usually we use the lone pair from where? Carbon monoxide is like that, right? With a dative inside, obviously. Yeah, so the lone pair usually from here, because of the dative bonding over here, usually we look at it this way. Carbon monoxide, that's how they attack the lone pair. I want to know where's the lone pair. Okay, these are all your monodentate. Now let's talk about cyanide. Cyanide, which one? The lone pair usually which one to attack? The carbon also. There's two more similar looking ones, and they seem to be keep coming out. Okay, let's do, I need to give you the English name itself. Give me a moment. Let me write up properly. So I just want to know what are the common ligands that they like to come up. I just want to prepare myself. Thiocyanate is one of them. This is isothiocyanate. I haven't put in the charge of the ion yet. All right. I'm going to put a negative sign to show you where is the charge. Lone pairs are here. These are the common monodentate ligands that we kind of keep seeing it in exam, one way or another. All right, could be data source or application, whatever you call them. All right, so we just be more careful with them. Okay, my cyanide, I forgot to put in my negative charge. Okay, Cn minus. So once again, every one of them has one lone pair to be datively to be contributed, right, through dative bonding to your central metal atoms or ions. So that is your monodentate, and then I want to take a look at the bidentate. Once again, there are two lone pairs. All right, this ion, we saw it before. Where have we seen this before? Got see before? No? Where? Organic chem. What is this? This is from ethene dioic acid. Correct? Give out the 2H plus, become ethene dioic ion. Yeah? So once again, this is bidentate. We're going to find two lone pairs on it. So these are all the example of the bidentate. So again, oxalate is actually this, right? Oxalate is just, I believe it's a common name. So once again, you are supposed, just I talk about this, right? The two lone pairs. Right? Once again, check out the negative charge. Find them. Okay? So this is how they attack. There are many, many types of them. I'm not going to memorize it. I just know that they all due to the lone pairs and it must have negative charge. If you would like to catch my latest videos, click on subscribe button right now. And click on the bell if you want to receive instant notifications once I've uploaded my latest video. If you would like to join my live chemistry classes and revision workshops, go on to winnerseducation.com and find out how you can score distinction for chemistry on a consistent basis, either in our center or online via Zoom. If you want to check out my online school, go on to passwithdistinction.teachable.com. You'll be able to learn chemistry concepts at your own pace and anywhere in the world, topic by topic. This is Sean Chua from Winners Education, to your distinction in chemistry.